replacing a 100 amp panel with a new 100 amp panel, and replacing the service entrance conductors without altering the conduit generally doesn't necessitate upgrading the meter or the mast. The National Electrical Code, or NEC, provides guidelines on this topic, focusing on maintaining the existing service capacity. The key principle here is that the replacement of service entrance conductors should not result in a reduction of the ampere rating compared to the original installation. Article 230.42 C of the NEC addresses this directly, stating that where service is changed, the ampere rating of the replacement service conductor shall not be reduced below the ampere rating of the replaced service conductors. In the scenario where you're replacing a 100 amp panel with another 100 amp panel and using the same size conductors, this requirement is an error limit. Since the ampacity of the service isn't being increased, the existing meter and mast are typically adequate to handle the load. Furthermore, Article 230.71 of the NEC does not mandate an upgrade of the meter or mast solely based on the replacement of the panel itself, provided the existing components are in good working order and meet the applicable code requirements for the existing service. However, there are exceptions to this general rule. Firstly, if the original service entrance conductors were initially undersized for the 100 amp panel, there might be a need to upgrade them to comply with the current NEC standards. This is because the installation, even if grandfathered in initially, may need to be brought up to code during any significant alteration or replacement. Secondly, if the meter or mast is found to be in poor condition, exhibiting signs of deterioration, corrosion, or physical damage, or if they present any safety hazards, then the replacement might be necessary regardless of the panel upgrade. Electrical safety is paramount, and any compromised component should be addressed proactively. Thirdly, local codes or utility regulations might impose additional requirements that could necessitate upgrading the meter or mast. It's crucial to consult with the local authorities and the utility company to determine if there are any specific regulations or requirements in your area that go beyond the NEC. Now let's delve deeper into the components involved. The service entrance conductors are the wires that connect the utility company's service drop or lateral to the main service disconnect in your electrical panel. Their size is determined by the calculated load of your dwelling, in accordance with NEC tables such as 310.16, which provide ampacity ratings for various conductor types and sizes based on their insulation and installation conditions. The meter is the device that measures the amount of electrical energy consumed by your household. Utility companies use this information to bill you for your electricity usage. The meter's capacity must be sufficient to handle the maximum load of your electrical service. The mast, also known as the service mast or weatherhead, is the structure that supports the service entrance conductors as they come from the utility company's lines to your building. It's typically a rigid metal conduit that extends above the roof line, providing a secure and weather-resistant entry point for the electrical service. When replacing a 100 amp panel, several factors should be considered to ensure a safe and code-compliant installation. Firstly, before commencing any electrical work, always disconnect the power to the panel at the main service disconnect. This is a critical safety precaution to prevent electrical shock. Secondly, thoroughly inspect the existing service entrance conductors, meter, and mast for any signs of damage or deterioration. Look for frayed insulation, corrosion, cracks, or other defects. If any issues are identified, they should be addressed before proceeding with the panel replacement. Thirdly, ensure that the new electrical panel is properly sized for the calculated load of your dwelling. This involves determining the total amperage of all the circuits in your home and selecting a panel with an adequate capacity to handle the load. Fourthly, when replacing the service entrance conductors, use conductors of the correct size and type as specified by the NEC. The ampacity of the conductors must be sufficient to carry the rated current of the 100 amp service. Fifthly, properly ground the new electrical panel in accordance with NEC requirements. Grounding provides a path for fault current to flow back to the source, helping to protect against electrical shock and fire hazards. Sixthly, carefully label all the circuits in the new electrical panel, indicating their function and the area of the house they serve. This will make it easier to identify and troubleshoot circuits in the future. Seventhly, after completing the panel replacement, thoroughly test all the circuits to ensure that they are working properly. Use a multimeter to verify the voltage and current readings at each circuit. Eighthly, obtain the necessary permits from your local building department before commencing any electrical work. This will ensure that the installation is inspected and approved by qualified electrical inspectors. Ninthly, if you are not comfortable performing electrical work yourself, hire a qualified and licensed electrician to do the job. Electrical work can be dangerous, and it's best to leave it to the professionals. Tenthly, keep detailed records of all the work performed, including the date of installation, the materials used, and the results of any inspections or tests. This documentation can be valuable for future maintenance or repairs. In addition to the above considerations, it's also important to be aware of the potential for arc flash hazards when working on electrical panels. Arc flash is a dangerous electrical explosion that can occur when a short circuit or other fault creates an arc of electricity. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, always wear appropriate personal protective equipment, or PPE, when working on electrical panels. This includes safety glasses, gloves, and arc-rated clothing. Furthermore, use insulated tools to prevent accidental contact with live electrical conductors. Also, be aware of the working clearance requirements around electrical panels as specified by the NEC. These requirements ensure that there is adequate space to safely work on the panel without obstruction. The working clearance typically includes a minimum depth, width, and height around the panel. When selecting a new electrical panel, consider features such as surge protection, which can help to protect your electronic devices from voltage spikes and surges. Surge protection devices, or SPDs, can be installed in the panel to divert excess voltage away from sensitive equipment. Also, consider the type of circuit breakers used in the panel. There are various types of circuit breakers available, including standard thermomagnetic breakers, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or SIs. GFCIs are designed to protect against electrical shock by detecting ground faults, while SIs are designed to protect against electrical fires by detecting arc faults. In summary, while replacing a 100 amp panel with a new 100 amp panel and replacing the service entrance conductors without adding to the conduit generally doesn't require upgrading the meter or the mast, there are exceptions to this rule. It's crucial to consult with the NEC, local codes, and utility regulations, and to carefully inspect the existing components for any signs of damage or deterioration. Electrical safety should always be the top priority when performing any electrical work. Remember to disconnect the power before commencing any work, wear appropriate PPE, and use insulated tools. If you are not comfortable performing the work yourself, hire a qualified and licensed electrician to do the job. By following these guidelines, you can ensure safe and code-compliant electrical installation. The National Electrical Code is updated every 3 years, so it's essential to stay current with the latest edition to ensure compliance. Local jurisdictions may also have amendments or additions to the NEC, so it's important to check with your local building department for any specific requirements in your area. It is also advised to consult with your local utility company, as they may have specific requirements for service entrances and metering equipment. They can provide guidance on the appropriate size and type of meter for your electrical service. The utility company may also require an inspection of the service entrance before connecting the new panel to the grid. This inspection ensures that the installation meets the standards and that the meter is properly installed and functioning correctly. When upgrading or replacing electrical panels, it's also an opportunity to evaluate the overall electrical system in your home. Consider whether you need to add any new circuits to accommodate additional appliances or equipment. If you are planning any renovations or additions to your home, now is the time to upgrade the electrical service to meet the increased demand. This may involve increasing the size of the service entrance conductors, upgrading the meter and mast, and installing a larger electrical panel. Upgrading the electrical service can also improve the safety and reliability of your electrical system. Older electrical systems may have outdated wiring, undersized conductors, and inadequate grounding. Upgrading the system can bring it up to current code standards and reduce the risk of electrical shock and fire hazards. Another important consideration is the location of the electrical panel. The panel should be located in a readily accessible area, free from obstructions. It should also be protected from moisture and physical damage. If the existing panel is located in a damp or hazardous location, it may be necessary to relocate it to a more suitable area. The NEC specifies the requirements for the location and installation of electrical panels. Be sure to comply with these requirements to ensure a safe and code-compliant installation. When working on electrical systems, it's always best to err on the side of caution. If you are unsure about any aspect of the installation, consult with a qualified electrician. They can provide guidance and ensure that the work is done safely and correctly. Electricity is a powerful and potentially dangerous force. It's important to respect it and to take all necessary precautions when working with it. By following the guidelines outlined above, you can ensure a safe and reliable electrical system for your home. This information is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Remember that local codes and regulations may vary, so it's essential to check with your local building department for any specific requirements in your area. Additionally, the NEC is a complex document, and it's important to understand the specific requirements that apply to your installation. Consider taking an electrical training course or consulting with an electrical inspector to gain a better understanding of the NEC. With proper planning, preparation, and execution, you can safely and successfully replace your electrical panel and ensure a reliable electrical system for your home.